This is a potential that we may face within the next 100 years, not the next million nor the next 1,000. If the Earth's magnetic field were to deteriorate severely, it may collapse entirely and reverse polarity, with magnetic north becoming magnetic south and vice versa. This process could have grave effects on our world. Hello everyone, and welcome to another video. Today we'll be looking at pole shift is happening. Earth's magnetic field is getting weaker. Yeah, you heard it right. Dr. Nicholas Tavenni of the European Center for Research and Teaching in Environmental Geosciences in the Aix-en Provence, France, stated that the geomagnetic field has been deteriorating for the past 3,000 years. If it continues to decline at this rate, we will enter a crucial time in less than 1,000 years. Since 2014, Dr. Tavenni has been one of the primary investigators of the 5-year EDIFICE project. Together with his colleagues, he has been researching the history of the Earth's magnetic field, including when it has reversed in the past and whether it would do so in the future. The majority of our planet's magnetic field is generated by the movement of liquid iron within its core. It has always existed on our planet, although its polarity has regularly reversed throughout the Earth's history. Each time it flips up to 100 times in the previous 20 million years, while the reversal can take up to a millennium to complete. It leaves fossilized magnetisms in the Earth's rocks. By extracting cores or columns of sediments from the sea floor, similar to a long straw that can reach up to 300 meters, with the use of a drill, we can determine when these reversals occurred by looking back in time. Dr. Tavenni and his team examined 2 specific types of elements that allowed them to investigate the history of the magnetic field of our planet in more detail. For polarity reversal to occur, the magnetic field must weaken to a threshold level by around 90%. During this time, the lack of a protective magnetic field around our planet allows more cosmic rays, which are high-energy particles from other parts of the cosmos, to strike us. This causes these cosmic rays to collide with an increasing number of atoms in our atmosphere, including nitrogen and oxygen. This results in the production of cosmogenic isotopes such as carbon-14 and beryllium-10, which then fall to the Earth's surface. By examining the amounts of these in cores, we can determine when polarity reversals occur. Between 772,000 and 774,000 years ago, the final reversal took place. Since then, the field is nearly reversed 15 times, which is known as an excursion. During each excursion, the field's strength has decreased dramatically without reaching the required threshold before rising again. As the field loses vigor and then regains it, this is the most dangerous time for us. The previous excursion occurred 40,000 years ago, and the evidence indicates that we are headed back in that direction. Dr. Tavenni stated that the geomagnetic field has lost 30% of its intensity during the past 3,000 years. From its value, we project that in a few years or millennia, it will approach zero. On our satellite's orbit, we can already observe the impacts of a decreased magnetic field. There is a huge stretch in the Atlantic Ocean between South America and Africa where the Earth's magnetic field is approximately 3 times weaker than in the poles. This is known as the South Atlantic Anomaly, the SAA, and it is the subject of Professor Chris Finlay's CoreSat study at the Technical University of Denmark, DTU, in close proximity. Using data from many satellites, notably the 3 swarm satellites launched by the European Space Agency, the ESA, in 2013, this research aims to determine the cause of the SAA. This is a region where we see that satellites consistently experience electronic failures, said Professor Finlay, and we do not know where this region of weak field is coming from, what is causing it, or how it may alter in the future. Since the 1950s, when scientists initially discovered the SAA, its strength has declined by 6%, and it has moved closer to the west. Professor Finlay stated that there has been no persuasive explanation for it, and that scientists have been unable to anticipate how it would evolve. The CoreSat project aims to change all of this by analyzing the magnetic field's properties and how they evolve over time by using the most precise data to date. By investigating the SAA, the team hopes to determine what is occurring within the Earth's core that may be causing it. One idea is that there is a large anticyclone in the liquid metal outer core of the Earth's southern hemisphere, which is displacing the magnetic field from the South Atlantic region. A second theory is that the magnetic field in this region is pointing in the wrong direction, resulting in a mini reversal of polarity. The SAA provides a first-hand view of how a weaker magnetic field might damage satellites. as multiple spacecrafts have reported technical difficulties and failures while passing through this region and being bombarded by cosmic rays. Professor Finley and his team will also study whether the SAA is related to the reversal of the Earth's magnetic field. In certain simulations, characteristics such as the SAA expand during a pole reversal. He explained it would not be surprising if something similar were involved in a magnetic reversal, although this is not necessarily the case. Nonetheless, the SAA may provide a peek of what lies ahead in the near future, in 1 or 2 millennia. The planet's magnetic field could reverse if current trends continue. Prior to that, the field may continue to deteriorate, and by the turn of the century, we may be confronted with grave challenges. The decrease in the geomagnetic field is much more important and dramatic than the reversal, said Dr. Taveni. It is very important to understand if the present field will decay to zero in the next century, because we will have to prepare. So that's all from today's video. If you enjoyed it, remember to leave a like, subscribe, and ring that bell icon so that you never miss our upcoming videos. And don't forget to share your thoughts in the comments section down below. Stay tuned, and we'll catch you in the next video.